In this video, we are going to discuss numericals related to lecture 1 and 2. Let's get started. The first numerical here is give approximate ratio of 1 astronomical unit and 1 light year. So here we have to find the ratio between 1 astronomical unit and 1 light year. What is 1 astronomical unit and what is light year? Please write in the comment box. So we know that 1 astronomical unit is equal to 1.496 into 10 raised to power 11 meter, and also 1 light year is equal to 9.46 into 10 raised to power 15 meter. So both the AU astronomical unit and light year are the unit of distance. So we have to find out the ratio of this. 1 AU divided by 1 light year is equal to 1.4696 into 10 raised to power 11 divided by 9.46 into 10 raised to power 15 meter, and here also meter. Now if we divide these two, we will get 0.16 into 10 raised to power, this is 11, and here we have 15 minus 15, so which is equal to 0.16 into 10 raised to power minus 4. So if we say the approximate value, we can take this as 1, we can write this as 1.6 into 10 raised to power minus 4. So this is the ratio of 1 astronomical unit and light year. So second question I have taken, the mass of an electron is 9.11 into 10 raised to power minus 31 kg. How many electrons would make 1 kg? So we have to find here the number of electrons in 1 kg. Find the number of electrons in 1 kg, which I have taken n, is equal to 1 kilogram divided the mass of 1 electron, which is equal to this 9.11 into 10 raised to power minus 31 kg. So this will get cancelled with this. So if we divide these two, we will get 1.1 into 10 raised to power 30. So number of electrons in 1 kg are equal to 1.1 into 10 raised to power 30. So this is my answer. So let's do third question now. So third question is, we have to check the correctness of this relation. V is equal to square root of 2 gm divided by r. Here V is the velocity, g is the gravitational constant, m is the mass, and the r is the radius of the earth. So for that, equate the dimensions of left hand side with right hand side. If the dimensions of the left hand side are equal to the right hand side, then this relation is correct, otherwise this relation is incorrect. Let me take left hand side. So left hand side is equal to v. So we know the v is the velocity. So this will the dimensional formula for velocity is m0 L t minus 1. If you remember, then it's good, otherwise you can derive the dimension formula for velocity from its formula, and we know the velocity is equal to distance divided by time. So from here you can find the distance dimension is L, and for the time it is t minus 1. So this is the dimensional formula for the velocity. Now I'll take the right hand side. So right hand side is equal to square root of 2 gm upon r. So g is the gravitational constant, m is the mass, r is the radius. If you know the the dimensional formula for g, you can put directly here. If you don't remember the dimensional formula for g, then you can derive it. We know the F is the gravitational force is equal to g m1 m2 divided by r square. So from here we know the g is equal to F r square m1 m2. So F, the dimensional formula for force, is equal to m lt minus 2 brackets, for r it is l square, and for m and m it is m square. So from here we'll get the dimensional formula for g is equal to 1 minus 2 L raised to power, this is 1 and here it is 2 plus 2 and t raised to power minus 2. So G is equal to m minus 1 L raised to power 3 t raised to power minus 2. So we can put that here. 2 is a non-dimensional constant, so we don't have any dimension for 2. So the dimension formula for G is m raised to power minus 1 L cube t raised to power minus 2 bracket closed, and for m it is m itself, and for radius r it is L. Now we'll solve this. So this right hand side is equal to square root of, this is minus 1 and this m will combine, will get m minus 1 and plus 1 L. This is here it has 3 power and here 1. So 3 minus 1 and t raised to power minus 2. So this is equal to, they will get cancelled, this and this, m raised to power 0, L raised to power 2 and t raised to power minus 2. So now if we take the square root of these, we will get m0 L t minus 1. So this is the dimensional formula for the right hand side. If we compare these two dimensional formula of right hand side and left hand side, both are same, so it means the dimensional formula for left hand side is equal to right hand side. So this relation is correct. So the question number 4th is, write the dimensions of a divided by b in this relation. F is equal to a square root of x plus b times t square. So here f is the force, x is the distance and t is the time. To solve this question, you should remember that we always add, subtract same units, physical quantities, and after adding or subtracting we'll get a physical quantity of same unit. For example, if we add force, we always add force with force, and after adding force with force we'll get a physical quantity which will be force only. Similarly for the subtraction also. So here given relation is f is equal to a square root of x plus b square root of t square, b multiplied with t square. So here we have to find a, we have to find here a divided by b, we have to find this. So here f is the force. So we know the dimensions of force are m1 L1 t raised to power minus 2 square brackets. X is the distance and distance dimensions are L, and t is the times dimensions are t. Now we'll write the dimensional formula for this relation. So f is the force, which is m1 L1 t raised to power minus 2 is equal to a square root of here we have L, so it will become L raised to power 1 by 2 plus b t square. T square means t raised to power 2. So we can write this as m1 L1 t raised to power minus 2 is equal to a L raised to power half plus b t square. So we know this will be a force and this is also a force. So we can compare the dimensions of this with force. So it means that a L raised to power 1 by 2 is equal to force. So the dimensions of force are m1 L1 t raised to power minus 2. So a is equal to m1 L1 t raised to power minus 2. This L will go 1 by 2 and this is equal to m1 L1 and this minus 1 by 2 t raised to power minus 2. So from here we'll get the dimensional formula for a is equal to m1 L raised to power half t raised to power minus 2. So let me mark this as equation number 1. Next is b t square is also equal to force m1 L1 t raised to power minus 2. So b is equal to m1 L1 t raised to power minus 2 divided by t square. So this will become m1 L1 t raised to power minus 2 minus 2. So b is equal to m1 L1 t raised to power minus 4. A divided by b is equal to, a is m L raised to power half T raised to power minus 2 divided by M1 L1 T raised to power minus 4, the dimensional formula for B. Now we'll solve this. We'll get M raised to power 1 minus 1 L raised to power half, this will become minus 1, and T raised to power minus 2 plus 4. So A divided by B is equal to M raised to power 1 minus 1 is equal to 0, L raised to power, this will become minus 1 by 2, T raised to power 2. So the dimensional formula for A upon B is M 0, L half and T square. Now let's do this fifth question. So a glass bubble from an explosion underwater oscillates with a period T proportional to P raised to power A, D raised to power B, E raised to power C, where P is the static pressure, D is the density of the water and E is the total energy of the explosion. Find the values of A, B and C. So here what they have given that the time period, this time period is proportional to P raised to power A, D raised to power B and E raised to power C. So we know this proportionality constant we can change with the sign of equality by putting one constant K. So T is equal to K P raised to power A, D raised to power B and E raised to power C. Here T is the time period. So now we'll write the dimensional formula for all the physical quantities involved in this relation. So for the time period, the dimensional formula is M0 L0 T raised to power 1, and for K there is no dimensional formula. P is the pressure, the dimensional formula for pressure. If you remember then it's okay, otherwise you can derive this dimensional formula for pressure by using its formula, that the pressure is equal to force divided by area. For the force, the dimensional formula is MLT minus 2, and for area the dimensional formula is L square. So from here we'll get the dimensional formula for the pressure, which is equal to M1 L raised to power minus 1 and T raised to power minus 2. So we'll put this value here. So we'll get M1 L raised to power minus 1 T raised to power minus 2 whole raised to power this A. So similarly for the dimensional formula for the density is equal to mass L raised to power minus 3 T raised to power 0 raised to power B, and for energy the dimensional formula is ML square T raised to power minus 2 raised to power C. Now we'll use the exponent law, which says that A into B whole raised to power C is equal to A raised to power C and B raised to power C. So here we'll apply the this exponent rule. So we'll get M raised to power 1 into A, L raised to power minus 1 multiply by this. So we'll get here minus A, and similarly for 2A, bracket closed. For now we'll write for this term. So M raised to power B, L raised to power minus 3B, T raised to power 0, and now we'll write for this M raised to power C, L raised to power 2C and T raised to power minus 2C, bracket closed. From here we'll get M raised to power this A plus B plus C, L raised to power minus A minus 3B plus 2C from here. Similarly for time, T raised to power minus 2A and minus 2C, bracket closed. So right side is M0 L0 T raised to power 1. Now we'll compare the dimensions of M, L and T on two sides. So we'll get here A plus B plus C for M is equal to this 0, and for L we'll get minus A minus 3B plus 2C is equal to 0, and for T we'll get minus 2A minus 2C is equal to 1. So we'll solve this. First we'll solve this one. From here we'll get A minus a minus c is equal to 1 by 2. So we'll get from here a plus c is equal to minus 1 by 2. Now we'll put this value of a plus c in this equation. So we'll get from here this a plus c is equal to minus 1 by 2. So we'll put here minus 1 by 2 plus c. B is equal to 0. So from here we'll get b is equal to 1 by 2. Now we'll put this value of b in this equation. So we'll get minus a minus 3 into 1 by 2 plus 2c is equal to 0. So from here we'll get minus a minus 3 by 2 plus 2c is equal to 0. So from here we'll get minus a plus 2c is equal to 3 by 2. Now solve this and this. So for that, minus a plus 2c is equal to 3 by 2 and a plus c is equal to minus 1 by 2. Adding these two equations, we get, this will get cancelled with this. So here we'll get 3c is equal to 3 by 2 minus 1 by 2. So we'll get 3 minus 1 divided by 2, which is equal to 2 divided by 2. So they will get cancelled. So we'll get c is equal to 1 by 3. Now we'll get the value of a by putting this value of c in a plus c is equal to 1 by 2 minus 1 by 2. So here a plus 1 by 3 is equal to minus 1 by 2. A is equal to minus 1 by 2 minus 1 by 3. So if we solve this, we'll get this minus 5 by 6. So a is this. So now we got the values of a, b and c. A is equal to minus 1 by 6, b is equal to 1 by 2 and c is equal to 1 by 3. This is what we have to find. Let's do question number 6. The density of a material in CGS system is 8 grams centimeter minus 3 in a system of units in which the unit of length is 5 centimeter, the unit of mass is 20 gram, and what is the density of the material? We have to find the density of the material in new system of the unit where the length is equal to 5 centimeter and the mass is equal to 20 grams. So let's see how we can do this question. So we know, so let's take this CGS system as first system of unit and this new system where the length is equal to 5 centimeter and mass is equal to 20 grams as the second system. So we know this relation N2 is equal to N1, M1 divided by M2 raised to power A, L1 divided by L2 raised to power B and T1 divided by T2 raised to power C. And the density, formula for density is equal to dimension formula density is equal to M1L raised to power 3 T0. So here we have A is equal to 1, this is minus sign here. So B is equal to minus 3 and C is equal to 0. Let me mark this as equation number 1. In system 1 as 1, so mass is given M1 is equal to 1 gram, L1 is equal to 1 centimeter and N1 is equal to 8. So in second system, they have given M2 is equal to 20 grams and length L2 they have given equal to 5 centimeter. Now we'll put all these values in equation number 1. So we'll get N2 is equal to N1 which is equal to 8. M1 is given 1 gram divided by M2 which is equal to 20 grams raised to power A. So A here is equal to 1 multiplied with this L1 which is 1 centimeter and L2 is equal to 5 centimeter raised to power B which is equal to minus 3 and T1 divided by T2 raised to power 0. So anything raised to power 0 is always equal to 1. So From here we'll get the value of n2 is equal to 8. This will get cancelled with this, divided by 20 multiplied with this will get cancelled with this, 1 by 5 raised to power minus 3. So we can write this as 8 into 1 by 20 into 5 raised to power 3. We can calculate this 4 and 5. This is 5 here. So we'll get here 2 into 5 raised to power 3 minus 1 is equal to 2 into 5 raised to power 2, which is equal to 50. So the density of the material in new system is equal to 50 units. So this is my answer. The 7th and the last question of this video is the number of the particle given by n is equal to minus t brackets n2 minus n1 divided by x2 minus x1 bracket closed are crossing a unit area perpendicular to x-axis in unit time. n1 and n2 are the number of the particles per unit volume for the values of x meant to be x1 and x2. What is the dimensional formula of diffusion constant d? So we have to find out the dimensional formula for d here. For that we can rewrite this formula as in term of d. d is equal to minus n x2 minus x1 divided by n2 minus n1. So here see what is this n? n is equal to the number of the particles are crossing a unit area perpendicular to x-axis in a unit time. The number of the particles which are crossing a unit area perpendicular to the x-axis. So we can write this as number of particles divided by unit area in per unit time. So for the number we don't have any dimensions, so for area this is equal to L square, and for t it is t. So therefore for the dimensional formula for n is equal to L raised to power minus 2 t raised to power minus 1. Similarly we can find out the dimensional formula for this x2 and x1. These are the length x-axis and y x1 and x2, it's like that. So dimensional formula for x2 and this is L. So dimensional formula for x2 and x1 is equal to L. Similarly for n2 minus n1. n2 and n1 are the number of particles crossing per unit volume. So this is equal to number of particles divided by volume. So we have to write the dimensional formula for that, that is 1 upon L raised to power 3. So this is equal to L raised to power minus 3. So here we'll put, so therefore the dimensional formula for d is equal to n, we have to put n is L raised to power minus 2 t raised to power minus 1, and the dimensional formula for x2 minus x1. Always remember that we always subtract or add the physical quantities having same units. So means that the dimensional formula for x2 minus x1 is the dimensional formula of length. So we'll put here L. Similarly for n2 minus n1, the dimensional formula will be L raised to power minus 3. So we'll rearrange it and we'll get, this is L raised to power minus 2 plus 1 minus 3 and t raised to power minus 1. So from here we'll get the dimensional formula. So here it will come plus sign. So from here we'll get L raised to power 2 t raised to power minus 1. So dimensional formula for d is equal to m0 L square t raised to power minus 1. So this is the dimensional formula for d. So thank you for watching.